Aloha, Richard Halverson here. This is ITS228. And today is Friday, January 27th, and we are going to do video number 4. Let's see, let me share my screen. And so we did this one like yesterday or something. Anyway, so we are here. See, when was the last? We did a class yesterday, and this one's today. Okay, great. And so when we look at the syllabus, we are in this week. Every class this semester, every syllabus I open up, I do that same thing. I want to move it. I want to select, and somehow this thing moves around, and I don't know if it's the browser or what. Anyway, so I'm going to talk more about sorting algorithms today. There's nobody here, so I'm going to try to do something new, and if it doesn't work out, I'm not boring you. I may splice out some areas, but what I'd like to do today is I'd like to look at the sorting algorithms that they give us. They give us Python versions of all these algorithms. And I'd like to make a program where I can compare how long it takes for them to execute. Okay. So I'm going to go to sorting algorithms here. And see, they give me Python selection sort, insertion sort, shell sort, quick sort. So I'm going to, don't give me heap sort, do they? Do they give me heap sort someplace? Well, anyway, that's too bad. I like heap sort. It's my favorite sort. So I'm going to open up a thing here. This is I'm just going to do it on my computer here because I'm going to run it on my machine right here. This is a new. Let me just close this, and I'm going to make a new one, and I'm going to save it as. I'm going to call it. I'm going to go into 228. I'm going to save it as sort comparison .py. All right, and let me take this and push this down here and put this over here. Take this and put it over here. Okay. So first I'm gonna. It's weird. So let me start with selection sort. Let's see, does it give me any code down at the bottom? This is, why is this? Hit my all right, so here they give me selection sort. They give me a bunch of numbers. You do the comparison. Okay, so I'm going to copy this. Start out with this, and I'm going to put that in here. And so I got selection sort here, and so first let me run this. Wait, and I always just start out from the beginning. Go back to ITS228, CD ITS228, and I got a bunch of junk in there, and I'm interested in sort comparison. This one here, I'm going to run that one. So I'm going to do Python sort comparison.py, and unsorted looks like that. Sorted looks like that. Okay, great. Now what I'm going to do is I'm going to make a much bigger array. So I got to know how to generate random integers. Python random number generator. Generate random numbers in Python. Um, import random. Random number between 0 and 9. Oh, that how you do it? Okay, let me just copy this. Copy, paste. Great, I'm the only one here. So right here, I'm gonna put this in there. Import random, and I'm gonna generate. Okay, so I'm gonna do four I in range 1000. Numbers append rand int a random number between 100 and 1 million. How's that? So that's what rand int does, right? And now I'm gonna make sure this code works, right? So I'll start with just 100, and I'll display the unsorted numbers. And this is going to append it onto this array. So we'll see that first, and then okay, let's just save this. I'm gonna see what this looks like. Okay, there. I appended on a bunch of numbers, and then when they're sorted, it looks like that, and took that many comparisons. Okay, so I'm gonna not print out. I'm gonna not print out the numbers anymore. Okay, I want to time how long it takes this thing to run. So how do I Python timer or something? Timer function. Let's see, timer functions. Monitor your code. Okay, so perf counter returns a time. Okay, so I'm gonna try this perf counter. I need to. Oh, I gotta import time. Okay, I gotta import time. Okay, that's how I do it. Okay, let me go back over here. Import time. And time perf counter is a start equals that. And I think I can do whatever. And equals the same thing. And what is this? What's the unit? In seconds? Okay, well, that's fine. It's going to be a fraction of a second. So then I say execution time equals end minus start. print x time seconds. And it's going to be some long number or whatever. I should use some sort of formatting. All right, I'm going to do this, and I'm not going to print out the unsorted numbers, and I'm not going to print out the sorted numbers, but I am going to print out the total comparisons, and I'm going to print out the time, execution time. So let me save this, and I'm going to go like this, and it says it took that many seconds. Okay, so that's how many seconds it took for, I'm going to do, print length of numbers elements in array. Save that. And now when I run it, it does too many these, I guess. (108) elements in the array, and it had that many comparisons, and that's how long it took. Okay, so that's 108 elements in the array. That's because I made 100. Well, how about if I do a million? Okay, a million elements in the array. I better not do that many. I'm going to do 10,000 elements in the array. 10,000 elements. It's taking a little while. It took 3.9 seconds for that. Okay, and that's how many comparisons it did. 3.9 seconds. Great, so now I got that. Now I got this for selection sort. Now I'm going to throw in some other sorts. This is pretty easy. Okay, I'm going to have an assignment where you do this. Okay, and I'm going to have you implement different algorithms that do the same thing and have you compare, actually run these kinds of tests, because this is the real stuff here. Okay, so let me go grab some other of these sorts. This is an O of n squared sort, selection sort. So is insertion sort. But quick sort is not. Quick sort is an O of n log n sort. This looks pretty complicated. Okay, well. All right, so let me just copy this. Okay. All right. So too much stuff going on here today. So I'm going to paste this in here. So that's my insertion sort. A selection sort's there. I'm going to paste this in. This is quick sort. And quick sort needs partition, and it needs quick sort, and it needs start index and end index. It's recursive. It's interesting. And it does, I don't need the number. This is how you call quick sort. Okay. So this is how you call quick sort. So first I'm going to, okay, so this is all I need in here, quick sort. This is how you call quick sort. And I'm going to, here's selection sort. Quick sort doesn't return anything, does it? No, it doesn't. Quick sort doesn't return anything. It just mutates the list. So I'm going to do this, just paste that there. And this, oh, this mutates the list also. Oh, so I don't want to, I want to use the same numbers list. Okay, so I want to make a copy of the list. So I don't want to just point to the same list again. I want to make a copy of the list. All right, I'm going to take this back out again. I'm going to take this, I'm going to reduce this down to 10 because I want to print it again because I want to be sure I know how to make a copy of the list. I'm going to make a copy of the list, do selection sort, and then make a copy of the original list, and then do quick sort and make a copy of the original list and do merge sort and so on. So in the meantime, I want to print all this stuff out, print out the sorted, and I can still print that out. This is a comment. And let me save this. I'm going to run this again to make sure I know what's going on. Okay, so this is, oh, this stuff is left over from up here. Let me get rid of this. And I'm going to get rid of this also. I got to define numbers. Define it as a list. Okay. This loads it up with 10 elements. Let me save this. And it says this is the unsorted list. This is the sorted list. There were 45 comparisons that took that amount of time to execute. So I'm going to make a copy of the list. Python, make a copy of a list. Oh, is that all? Okay. Copy, great. Simple, okay, good. Do that. So I'm going to say, numbers is this. I'm going to say numbers original. No, I just say numbers is that. And then this will be the length. And then I'm going to say, I'm going to say, yeah, I'm going to say make this original. I'm going to just say original numbers. I'm going to call the original that. And then I'm going to make a copy. This is going to be original numbers. It's the length. And then I'm going to say numbers equals original dot copy. And I'm going to print out the unsorted. Print out the unsorted, and it's going to do a selection sort. And it's going to print out the sorted version. I don't care about the comparisons anymore. I'm not going to bother with that. Okay, but the first one is going to be insertion sort. I mean, selection sort. Print selection sort. Okay, and so that's going to Just grab it, print it out, call selection sort, print print the sorted list, because it mutates it, and then it prints the end time. Oh, it prints this. Copy this, and I'm going to put that here. And where's the start time? Start time is, copy this, and I'm going to say it starts right here. It's not a good task. Okay, so this is the start time. It does a sort, and this is the end time. I'm going to put this after, right after we're done with the sort, and it prints out the sorted list, computes the time. Okay, now we're going to do the same thing with insertion sort. I mean with quick sort. Copy this, and I'm going to paste this here, and this is going to say quick sort, and it's going to be, this is going to be the, what calls it, and that's going to go right here. Okay, so this should show me both of them. Let's see if this works. Okay, so it took that amount of time to do selection sort, and it took, those are big. Oh, times 10 to the minus fifth. Okay, times 10 to the minus fifth. That's what that is. Okay, seconds, and this is 2. So this is, it took longer to do quick sort with these 10 elements. So let me, I'm going to, oh, let me make sure it is sorted, right? Yes, it's sorted. Okay, in fact, why don't I make it so these numbers are not so big, between 1 and 100. I guess I gotta make it bigger. Okay, this is 1 in a million. All right, so instead of I'm gonna do 1,000 numbers. Let me get rid of these stupid dots. And I'm not going to print the unsorted numbers. And I'm not going to print the sorted numbers. Oh, I wanted to check. These are the same, right? This is same original list. Yeah, it starts the same. This list is the same as this list. And the sorts are the same. Okay, good. So they are the same. It doesn't unsorted. So okay. So I got rid of this print. I got to get rid of this print because it's too big now. This print. Okay, so now it's 1,000. Let's print this. And it took, quick sort was quite a bit faster. Let's do 100,000. I just went too high. I shouldn't have gone so high. 1,000 to 100,000. So it's going to take it's old n squared. So this is, I'm going to quit this. Control Control C. Oh, okay, Control C. All right. I'm going to change it to. I'm going to read input. Let's say size equals int input enter array size. And this is going to be size. Now I can just compare them. All right. So it's going to ask them each time now. All right, so first one, array size, I'm going to do 100. And it takes that amount of time. Okay, I'm going to do 1,000 now. Oops. 1,000. Quick sort's quite a bit faster. Let's do 10,000. 10,000. Selection sort takes 4 seconds. Quick sort takes 1/100th of a second. Okay, so it gets pretty high pretty fast with the O of n squared. So what time is it? It's 12:43. Okay, well, good. So what I've done is I've copied in 2 of these sorting programs. I've copied in quick sort and I copied in selection sort. And I could go further, but see, this class, hold on a second. This class goes until, oh, I have another half an hour in this class, don't I? Let me look at my schedule. Let's see, where's my, well, I know that I've got another half an hour. Let me just look at the 228 announcements. And this goes until Thursday, it goes to 1:15. Okay, great, good. So I'm gonna pop in a couple more sort programs, and I'm gonna turn this into a program, something that I can just run, and then I'll be done. And then this will serve as a model for what I'm gonna have you do in the future. The kinds of things I'm gonna have you do in the future, where because they give you the programs pretty much here. There's gonna be some new coding soon, but this is a good way. In this is 228, so we got to spend a lot of energy analyzing the computational complexity of these algorithms, and what does O of n squared mean, and what does O of n log n mean? You know, we just sort of demonstrated that as we increased the size of the array. Selection sort started to take a really long time, you know, pretty quickly, whereas quick sort, it looked like it could handle many more. So I'm going to throw in a couple more of these. Let me go back to here, and that was quick sort, shell sort, insertion sort. I'm going to do a merge sort. Kind of like merge sort. Does it have the code down here at the bottom? This is nice. Give you the code down at the bottom. Cat. All right, this is merge sort. I'm going to pop that in, I don't know, right here, maybe. Okay, so this is merge sort. Merge calls itself. And this is for quick sort, selection sort. Merge sort is going to be, so add that. Merge sort looks like this. Merge. And that's going to go right here. merge sort. And then I'm going to do, let's put in some more. Let's put in sort. I've never coded this one before, but let's put it in. So I just got to copy here down to here. Copy. And this one is going to be radix. Here. And let me put in radix. Radix. And where do they call? How do they call it? Just like this. Okay, so now we've got radix, got all the sorts. And I think I'm going to leave off I'm going to do this. I'm just going to skip selection sort. And the way I do that is I put a dit and a dit. All right, so that just cancels out selection sort. So I'm going to be comparing quick sort and merge sort and radix sort. Okay, so these are, so let's look at this. We compare the sorts. This one, fast sorting. Selection sort was O of n squared, that took too long. Quick sort is O of n log n, merge sort is O of n log n, and radix sort is O of n. Heap sorts O of n log n too. So maybe I should throw shell sort in there and compare selection, insertions, and shell. I might as well do that while I'm here. So let me go to shell insertion sort. Insertion sort's pretty dang easy. It's pretty dang nothing. Insertion sort numbers. Let's see, this is selection sort. I'm going to copy. And I'm going to do insertion sort right here. And I'll come back to this later, and it's insertion sort. And it's just, I think you just call it this way. I realize these are this is commented out, but I'm just putting these in now, and I'm going to come back to it. This is insertion sort, and I was going to throw in shell sort. Shell sort. I wonder what this, not super familiar with insertion sort, but a shell sort, but let me copy this in and gap values, that's right. this is shell sort. And that can be called, let me just copy this, shell sort. And I guess that gets called with something that looks like this. To display out the number of swaps, I guess. Okay. So anyway, I'll leave those there, and but let's compare these three O of n's, O of n log n, O of n log n, and this is O of n. Yes, was one of those. So we're looking at fast sorting algorithms, and apparently a radix sort looks like that. Some limitations though, but all right, so let's save this, save, and let's start by going array size. So the last one we did was 10,000, and quick sort took that, merge sort took that, and radix sort took that. Let's do a bigger number. Let's do 100,000. Quick sort, okay, merge took the longest. That's 100,000. Let's do 1,000,000. Okay. Wow. Radix sort. It's been pretty close to merge sort. Let's do 5,000,000. So quick sort took 17. When we went to from 1,000,000 to 5,000,000, quick sort went from 2.8 to 17.4. We'll merge sort. Looks like it's going to be 36 seconds. What's radix sort? It's smaller than quick sort. Okay, well anyway, let's take a look at these other ones now. Let's compare these three. I'm going to remove this and make the comments. I'm going to comment out these. That doesn't, these ones down there don't matter because they're going to be fast anyway. So let's just compare. Let's do smaller numbers and compare these top three. The bottom ones can stay. It doesn't matter because they're just going to be real fast. Array size of 100. Let's do 1,000. I'm sorry, I did 1,000 before, didn't I? Let's do 10,000. Selection sort takes 3.9 seconds. Insertion takes 5 seconds, and shell sort takes 1.5 seconds. Okay, that's interesting. All right. Well, anyway, I think I've taken up enough time today. So I just took the time here to implement all of the sorting routines that were provided for us in chapter 3. They gave us all the Python versions. I put them together into one big program, and pretty easily you can replicate this yourself. And we're going to be doing these kinds of things for other data structures, ways of storing data and traversing data in the future. So I hope this helps. See you next time. Thanks for watching.